Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In September of 2015, for the first time ever, an image was captured of an elusive electrical phenomenon above the Earth. An astronaut aboard the International Space Station imaged a kind of electrical discharge in the upper atmosphere, known as a blue jet. It wasn't until the mid-1990s that scientists were able to verify this kind of intense electrical activity above thunderclouds, reaching towards space, though some airline pilots had claimed to witness the phenomena for decades prior. Scientists today acknowledge they don't fully understand blue jets, or another form of above-clouds lightning, called red sprites. Yet surprisingly, as far back as the 1920s, a Scottish physicist named C.T.R. Wilson predicted the existence of brief flashes of light above large thunderstorms. A fundamental question that must be asked is, do scientists today really understand lightning? Much of what we observe in nature and recent scientific research suggests that the answer is no. In 2001, a physicist named Professor Edgar Bering at the University of Houston flew a high-altitude balloon above a thunderstorm. He made the unexpected discovery that when lightning strikes occur above and below the clouds, the electrical charge was already present and did not take time to build up between lightning strikes. This contradicts the standard notion that lightning is a generator of the clear air electric field, measured at about 100 volts per meter between the Earth and a clear sky. Lightning's generation of power requires water droplets to separate charge in clouds, a process that remains mysterious and unverified. The Electric Universe, however, sees lightning and the cloud activity as a load that is being driven by electricity from space, and it is the electrical circuitry between the Sun and the Earth that drives all lightning. Recent scientific studies have confirmed the role of the electromagnetic Earth-Sun connection in lightning. In 2014, scientists in the UK discovered a dramatic increase in lightning strikes for up to 40 days after a major solar storm. The researchers admit they don't understand the cause of the increased lightning, suggesting that the collision of protons with gas particles in the atmosphere, quote, somehow alters the electrical properties in the air. The role of electric currents from the sun in creating lightning may be even more clearly evidenced on other planets. For instance, on the planet Venus, no water clouds are present, but rather, the atmosphere is composed of what has been characterized as a, quote, fog. Yet when the Soviet Union's Venera spacecraft touched down on the planet in the early 1960s, it found constant lightning activity, from tens of kilometers down to a couple of kilometers altitude, with discharges occurring as frequently as 25 per second. In contrast, the highest recorded rate on Earth is 1.4 per second. In the Electric Universe, Venus is a charged body immersed in an electrical circuit. This means that Venus is the focus of a cometary-style discharge to the solar electrical environment, a fact evidenced by Venus's enormous filamentary magnetotail. A new understanding of lightning on Earth and other planets may help to enable a radical reassessment of mysterious atmospheric phenomena on many planets and moons. The recently imaged blue jet bears a resemblance to some of the so-called volcanic plumes on the Jovian moon Io. While planetary scientists believe that tidal heating creates cryovolcanoes which generate the plumes, recent studies have shown that these models have failed to predict the locations of the plumes. Similar plumes are also seen on the Saturnian moon Enceladus. And in 2015, scientists were stunned when giant plumes were imaged jetting hundreds of kilometers above the surface of Mars. The electrical connection between a planet and the sun has enormous implications for the safety and efficacy of all future space missions. In the 1990s, the Thunderbolts Project's chief science advisor, physicist Wal Thornhill, offered a prediction and warning about a space tether experiment in which a satellite was flown at the end of a long wire held radially from the Earth. Thornhill warned that by trailing a wire radially, scientists would achieve voltages that could prove destructive. The prediction appeared to be confirmed when the tether separated at the shuttle, and the satellite at the end of the tether was lost. Thornhill also warns against plans to build a so-called space elevator, which would enable astronauts to travel up and down a kind of elevator cable between the Earth and space. Such an elevator is, in Thornhill's opinion, an impossible dream, since it could only act as the ultimate lightning rod. It is telling that lightning, nature's most dramatic electrical display on Earth, maybe providing scientists with the most obvious clues to the electrical nature of the Sun, the Earth-Sun relationship, and of the universe as a whole. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.